Hi everyone. In today's lesson, we're going to talk about an alternate definition of the derivative. So yesterday in class, we discussed the limit definition of the derivative, which is this guy. And today we're going to talk about another definition, which we call the alternate definition, which is this one. Now I see that there's a typo here. This actually is f prime of a, not f of x. So please make sure you make that change. So the definition says f prime of a is equal to the limit as x approaches a of f of x minus f of a all over x minus a. So how is this formula different than yesterday's? First, let's put this in as a also, f of a. So here's an example, right? We have used both the limit definition of the derivative and the alternate definition to find the derivative of this at x equals -1. So the key difference between these two formulas is that you have to understand that the limit definition of the derivative just gives you the derivative equation, f prime of x. So derivative equation. To find, so see how it says evaluate the derivative at x equals -1? If you want to find the value f prime of a, so say at -1, right? F prime of -1, you must plug in f prime of x, right? If I want to do that. So this is two steps, right? But the alternate definition of the derivative, f prime of a, goes straight to evaluating the derivative. It does not give you the derivative equation. So it does not give f prime of x, but gives you f prime of a, which is the evaluation of the derivative at a specific value. So what I'm going to have you guys do is you're going to do this piece for homework, right? You're going to do the limit definition of the derivative because we did that yesterday. So what we're going to do is I'm going to show you how this alternate definition of the derivative works, and I want you to prove that the answers are the same. So the question is asking us to evaluate the derivative at x equals -1. So that's your a value. So we want to find f prime of -1. So what we're going to do is we're going to plug into this equation, and every time we see an a, we're going to put a -1. So here and here. So let's go ahead and rewrite what we have. We have the limit as x approaches. Now instead of a, we're going to put -1. And f of x, this piece, is your original function, f of x. So we're going to go ahead and put that in. So x squared minus 5x plus 2. And then our minus f of a, we're going to go ahead and substitute our a value to be -1. So f of -1. And then the bottom is x minus a. So x minus our a value is -1. So double negative. So notice I put the a here, here, and here. So here, here, and here. F of x is your original function, and this is your f of -1. So before I can simplify this any further, I need to figure out what f of -1 is. So what that means, notice the notation. It's f of x, not f prime. So we're going to plug f of -1, which is plug into our original function. So I'm asking you, everywhere you see an x, to put in a -1. So -1 squared minus 5 times -1 plus 2. So you can trust my math. This will come out to 8. So f of -1, I'll just continue it over here. F of -1, you add up all that stuff, it gives you 8. So everywhere I see f of -1 now, I'm going to put 8. So we have x squared minus 5x plus 2. And then I'm going to put minus, right, because there's a minus here. And then we're going to put 8. And then we're going to divide that by x minus -1. That's a double negative, so we can make that x plus 1. And again, we always have to bring down everything just like we did yesterday. And on the numerator, it looks like I can combine these two terms. 2 minus 8 is -6. So x squared minus 5x minus 6 over x plus 1. Again, we're bringing down our limit as x approaches -1. And we're moving down Okay, so now normally when I evaluate a limit, I usually try direct substitution first. So if I do that, my direct substitution, we will see that it's negative 1 squared minus 5 times negative 1 minus 6 over negative 1 plus 1. Now you can trust my math that this will be 0 over 0, which means there's a hole. The only way out of the hole is by factoring. We're not going to use conjugates or common denominators. So let's factor. What adds to negative 6, negative 5? That multiplies to negative 6. That's x minus 6 and x plus 1, all over the x plus 1. Now again, we are still taking this as the limit as x approaches negative 1. These will cancel. So we have f prime of negative 1 is my limit as x approaches negative 1 of x minus 6. So now we can do direct substitution again. And when we do direct substitution, the limit goes away. So f prime of negative 1 is when I directly substitute negative 1 for x. So negative 1 minus 6 is negative 7. So what you just found, just so we keep practicing, you found the slope of the tangent line at x equals negative 1. Okay, so what you're going to do now is you're going to try to do this the same way. You're going to use the limit definition that we did yesterday. You're going to get the derivative equation, and then you're going to plug in negative 1 and see if you get that same slope value, which should be negative 7. All right, let's move on to the back. So I have another example, same thing, use the limit definition and the alternate definition to get us our answers here. So again, you're going to try this one for homework, and we're going to do this other one here now. Remember, the a needs to be changed. So we're going to find f prime of a. So in this case, they're asking at x equals 7, so a equals 7. So we want to find f prime of 7, and we do our limit as x approaches 7. Remember, everywhere I see an a, we're going to put in 7. Our f of x is our original equation, so this guy, minus f of a gets 7 again, and then the bottom, x minus a this time again, a is 7, so we put 7 here. So just like we did before, we can't do anything with this until we figure out what f of 7 is. So let's jump to our original function, and we want to find f of 7. So the square root of 7 plus 2. 7 plus 2 is 9. Square root of 9 is 3. So f of 7 is 3. So let's go ahead and plug that in. So f prime of 7 is the limit as x approaches 7 of rad x plus 2. Now instead of f of 7, we're putting in 3. That's what it equals. All over x minus 7. So again, in order to evaluate a limit, we always should try direct substitution first. So direct sub, we put in 7. And trust my math again that we get 0 over 0, which means there's a hole. So the only way to evaluate this limit is going to be factoring, conjugates, or common denominators. I'm just rewriting it. So because I have a radical, we're likely going to use conjugates. So we're going to multiply top and bottom by the conjugate of the numerator. Conjugate means to switch the middle sign. So we're switching this sign with this sign. Whatever I do to the top, I have to do to the bottom. And we're going to simplify. Remember with conjugates that we're only multiplying the first and the last. So rad x plus 2 times rad x plus 2 is itself x plus 2. And negative 3 times a positive 3 is a negative 9. And we leave the bottom alone. And we're bringing down our limit as x approaches 7. And we can quickly decide that 2 minus 9 is negative 7. So we could really make this x minus 7, which you should see cancels with that. Anything divided by itself is 1. So f prime of 7 is the limit as x approaches 7 of 1 over rad x plus 2 plus 3. So last and final step is to evaluate the limit. And the way we evaluate the limit is by simply plugging in 7. So the limit goes away now. So 7 plus 2 plus 3. So f prime of 7. 7 plus 2 is 9. Square root of 9 is 3. 3 plus 3 is 6. So 1/6. So again, what you found the slope of the tangent line at x equals 7. Okay, so for homework, you are going back and you are trying to get the same thing using the limit definition of the derivative. All right, that's it for tonight. We will go over both of these homework problems tomorrow. Have a good night.